So today we have with us Ethan Tevis, who is Cat motor grader integration engineer. And what we want to talk about is our power strategy on next gen graders. It started with our 120 next gen, and it's something we're going to continue with the 140, 150, 160 next gen machines. Ethan, this power strategy is called constant net horsepower. And how does this differ on the next generation machines than on our previous machines?
Hey, Eric, thanks. Yeah, that's a great question. Let's start a little bit with some background. Our machines, we have our gross engine power. And then, of course, machines have losses, right? So you have powertrain losses, you have alternator losses, all these things, and fan losses. And for the most part, those losses are pretty consistent, for a given engine speed and machine speed, except for the fan. That can vary a fair amount depending on what type of work you're doing, depending on your ambient conditions. So in the past, like before the 120 programs, depending on all that, your fan speeds go up and down, and then your available power to do work under the ground changes over time. So we advertise in the past our max capability. So basically min fan speed, here's your max power, and then it can go down. So with our next gen product, starting with 120, as you mentioned, Eric, really what we wanted to do was make sure that that power available for the operator to do work, the machine to do work, was always the same. So no matter what your fan speed now on next gen, we compensate for that basically with increasing the gross engine power to make sure that you always have a consistent feel, always have that same drawbar pull, no matter what your condition, whether it's high ambient or heavy load. That was the concept, and it really comes to fruition. Now you don't have to worry about if you're working in high ambience, et cetera. You know what you're going to get as an operator in that certain gear and machine speed and application.
So are you saying in a high fan load scenario, constant net horsepower actually provides more power to the powertrain than our previous generation machines?
Yeah, that's right, Eric. In fact, it does. Even though on our advertisement, the net power will actually look a little bit lighter, but the reality is your available power to do work at what we call drawbar power is actually higher or the same across the gears.
So constant net horsepower is compensating for the fan load, so that you have that constant. Is there other things we've done with this next generation to provide more power to the ground beyond just the constant net horsepower strategy?
Sure, yeah. Some small things. We've also worked on some of our powertrains efficiencies so that we have to provide less total power to accomplish this. So what that means to you as an operator, as a consumer, customer, is fuel savings, right? So we don't have to put as much power to get the work out. So that's the main thing. Some efficiencies were improved. Our park brake, for instance, has lower losses than in previous generations.
So this is more of a power when you need it versus just giving you the power, and it may or may not be enough.
Absolutely. Consistency, and it's always there if you need it.
So as an operator or a customer that would purchase one of these, what are they going to see? And, that published horsepower isn't going to be as high. What value are they going to see in this whole setup?
I think that on the highest level, they should expect the same or better performance as they come to expect from a Caterpillar motor grader. Even though the advertised number is a little bit lower, their ability to do what they want to do is there or improved. So it'll have that same feel, that same drawbar power that they're used to having. Pull as much dirt as you want on that thing. It'll do the job.
Awesome. Well, that's a good news story. That's nice to know that we got power when we need it, and that power to the ground is a higher, more or increased power to the ground with this next generation machine than we did with previous. So, thank you for the explanation.
Thank you, Eric. Have a good one.